This podcast is on the topic of literal equations. Literal equations are equations with many letters in it. Like, for example, in our problem 1, we have the letter P, the letter T, and the letter F. Now, pi, this symbol here, is not actually considered a letter. It's considered a mathematical constant. It's the number of diameters that it takes to go around a circle. We're going to be using, and this is the good news, the same 5 steps that we just used for general linear equations. The 5 steps for solving linear equations work just as well on literal equations as they do on other equations. Just to recall the 5 rules, the first thing we want to do is if we have fractions, we want to remove them. We locate the common denominator. Then we multiply every term. Whether the term has a denominator or not, we multiply every term by the common denominator. Now recall that terms are separated by plus signs, minus signs, or equal signs. We then take the objective variable. The objective variable is our objective in the problem. For example, in number 1 it's t. We want to solve for t, and in number 2 it's L. We call that the objective variable because that's our objective. We want to get it out of a grouping symbol if it's in a grouping symbol. And if it is in a grouping symbol, we get it out by the distributive property. The next thing we want to do is get all our, and what I'm calling here, x terms. Now x, I really mean the objective variable. I just didn't want to write out the words objective variable every time because it gets kind of cumbersome. So in this part I just called it x. Get all x terms to one side and all non-x terms to the other side. And remember, it may not be x. If you're solving for L, then it's get all L terms to one side and all non-L terms to the other side. Now, when you end up with this, you end up with more than one x term, then you want to combine them all together into one term. And the way you do that is by factoring out. For example, suppose I had ax minus 4x. That's 2 terms separated by a minus. If I factor out the x, I get a minus 4 times x, and that's now a single term. And it's the same as it was before. Just distribute the x and you'll see that you get what's right above it there. So that's going from 2 x terms to a single x term by factoring out x. Once you get down to a single x term, then you want to reverse what's done to x. And to reverse what's done to x, you need to know what's done to x. So give that one some thought. Okay, let's begin. Number 1. The equation is P equals 2 pi TF, and we want to solve that for T. Well, we don't have to get rid of fractions. That would be step 1. There are no fractions here. Step 2 says get T out of the grouping symbol. There are no grouping symbols here. Step 3 says get your T terms on one side. Well, I only have one T term, so it has to be on one side. Step 4 says form a single C term. A single just means one T term. That is one T term. So I didn't have to do steps 1, 2, 3, or 4. All I have to do is step 5, reverse what is done to T. Well, let's think about what's done to T. This is all multiplication, so the 2, the pi, and the f are all multiplying T. So if I want to reverse that, I'll just divide by the 2, the pi, and the f. But I have to do it on both sides. The 2's cancel, the pi's cancel, the f's cancel, and I end up with t equals p over 2 pi f, and we've solved the first problem. Let's go on to the second problem. In the second problem, for the first time, we see a fraction. And step 1 says get rid of those fractions. Multiply every term by the common denominator. Now, terms are separated by plus signs, minus signs, or equal signs. There are no plus or minus signs. So we only have 2 terms separated by that equal sign. Our common denominator in this case is our only denominator, 2m. So I'll multiply 2m by each term. So I get 2m times x is 2m times negative EL over 2m. And on the right side, the 2m on top cancels the 2m on the bottom, leaving me with 2mx equals negative EL. Step 2 says get L out of the grouping symbol. There is kind of a big grouping symbol here, but the only thing outside of it is 1. So if I distribute my 1, that removes the grouping symbol, and I get negative EL is equal to 2mx. Step 3 says get my L terms on one side. I only have one L term, so it's got to be on one side. And get your non-L terms to the other side. I have one non-L term, and it's on the other side already. So I don't have to do step 3. Step 4 again says form a single L term, and this is a single L term. And step 5 says reverse what's done to L, and L is multiplied by negative E, so I divide by negative E. And I get L is equal to 2mx over negative E. Now, it's not considered elegant to leave a negative on the bottom. You can either put it in front, like this, negative 2mx over E, or you could put it on the top, negative 2mx over E. And that's your final answer. Let's go to the third one. In the third one we have in the third one we have 2 terms, and we also have 2 fractions. So now we need to locate a common denominator to get rid of the fractions. If your fractions were 1/2 and 1/3, you just multiply these together to get a common denominator, and that's what we do here. We get 3 times d minus f by just multiplying our 2 denominators together. So I want to multiply that by each term to get rid of my fractions. So 3 times d minus f, and that's a capital F now, as distinguished from the small f. Notice the 2 f's. They're different variables. If you use a different symbol, you have a different variable. So I could have called that A, and I could have called that B, for example. But for some reason, we wanted to call them both f, so we do that. So we take 3 times d minus f, and we multiply it by the first term, 2f over 3. And then we take 3 times d minus f, and we multiply it by the other term, f over d minus f. Now you can see why the d minus f had to be part of the common denominator, because we're going to cancel the d minus f with the d minus f. Be careful there. When you've got an expression like d minus f over d minus f, you're not canceling the d's and you're not canceling the f's. You're canceling the whole expression with the whole expression. And that's the way I showed it here. And on the other side, the 3 cancels the 3. Now I'm solving for capital F. And let's see, am I solving for capital F? It didn't say what I'm solving for. Doesn't say on the sheet either, so I'm just going to say for F. We're solving for capital F, and capital F is in the grouping symbol. So to get capital F out of the grouping symbol, I'm going to distribute the 2f here and here. So I get 2 little f d minus 2 little f big F equals 3 big F. And we have done step 1, get rid of fractions, and step 2, get big F out of the grouping symbol. Okay. Step 3, get all my big F terms to one side and all my non-big F terms to the other side. This is my only non-big F term. So if I get this big F term over to the right, I will have done step 3. All my big F terms will be on the right and my non-big F term will be on the left. So to do that, I'm going to add 2 little f big F to both sides. And I get 2 little f d equals 3 big F plus 2 little f big F. Now, next step, and I think I'm going to need some room here, so I'm going to clear out some room here. Next step is to form a single big F term. That would be step 4. And it says form that single big F term by factoring out big F. Notice I have big F in both terms, so I can take that out as a common factor. So I'll have 2 little f d equals big F times something that goes in here so that I end up with 3 big F times 2 little f big F. So here I want a 3 plus 2 little f. And so I've done step 4. I've now formed this into one single big F term. Remember, when numbers are in a bracket, we count it as a single number. So there is no plus, so this is just a single term, big F bracket. Okay, big F is multiplied by the bracket, so to reverse that, that's step 5, I divide by the bracket. So I'll have a big bracket here, and I'll just cancel those out. My big bracket has in it 3 plus 2 little f. Now, notice that I cannot cancel the little f's. That takes me inside this bracket where there is a plus, and you can't cancel where there's a plus. So my final answer is 2 little fd over 3 plus 2 little f. Now, this last problem we're going to work in a couple of ways. The first time we're going to solve it for t. Note that t is in a bracket here. So step 1 says get rid of fractions. We don't have to do that. No fractions here. Step 2, and by the way, let's talk about n1 and n2. In the last problem, we had little f and big F. That was a way to use the same basic letter to represent two different variables by using one small letter and one capital letter. Here we see another way to represent. This time we're going to represent 3 different variables. For some reason we want to call them n. And I'm not sure exactly why that is, but for some reason, maybe each one of those variables starts with the letter n. We want to represent them with an n. And we've got here 3 different variables. N without a subscript, n1, and n2. And that might just as well be called A, B, and C. They are 3 different variables. For some reason, we want to use the letter n to represent them, so we've used n's on all of them, but made 3 variables out of it. Okay, we're solving for t. T is in the grouping symbol, so we want to get t out of the grouping symbol by distributing. So we'll say n equals n1t, and then we're going to distribute our negative n2 here. So it's going to be negative n2 plus, because it's negative times negative, plus n2t. Now we've got our t out of the grouping symbol, and we go on to step 3, which says get all t terms to one side. Well, all my t terms are already on the right, so I've done that. But then it says and, in great big capital letters, all non-t2 terms to the other side. Well, here is a non-t term. So I'm going to add n2 to both sides, and that's going to move that term to the other side. So I'll have n plus n2 is equal to n1t plus n2t. Step 4 says form a single t term. Right now these 2 t terms are separated by the plus. To form a single t term, just like last time, I have to factor out the t. So I'll call this t times n1 plus n2. If you want to put the t on the back side, that's fine. Multiplication is commutative. And n plus n2 on the front. And now step 5, reverse what is done to t. T is multiplied by the bracket. You divide by the bracket, and make sure you do it to both sides. And on this side, the 2 brackets cancel. And on this side, you get n plus n2 over n1 plus n2. Don't cancel. These are different. That's an n. That's an n1. They're not the same. That's a plus, so canceling is not allowed. You have a nice, clean, simplified answer here. N plus n2 over n1 plus n2 is equal to t. Now, I want to try number 4 again, but this time, instead of going for t, I'm going to go for a different variable. So let's flip to another page here. This time we have the same equation, n equals n1t minus n2 times 1 minus t. Oops, it says for t, but this time we want to solve for n2. Last time we solved for t. Let's begin. No fractions. So we don't have to do step 1, get rid of fractions. Step 2 says get the objective variable out of the grouping symbol. This time we're solving for n2, not for t. n2 is not in the grouping symbol. To get n2 out, we would distribute if n2 was in there, but don't distribute. n2 is not in the grouping symbol. Just go on to step 3. And step 3 says get all your n2 terms on one side and all your non-n2 terms on the other side. There's a couple of ways to do this. Probably the easiest way is just to move n1t, but I will find it easier in the end to solve for n2 if I don't have this negative here. So what I'm going to do is I'm going to move this term over to this side and this term over to this side, and that's going to get rid of the negative on my n2. So on the left I'll have n2 times 1 minus t. On the right I'll have n1t minus n. Everybody follow that step. Think about that for a minute. What I've done is I've gotten rid of the negative, so as I go to solve for n2, I don't have to worry about the negative. Okay, step 4 says form a single n2 term. That is a single n2 term. This minus is in a bracket, so that's not separating terms. This is all one number, so this is all one term. So we've already formed our single n2 term, so step 5 says reverse what's done to n2. n2 is multiplied by the bracket, I divide by the bracket. And I get n2 equals n1t minus n over 1 minus t. Again, I cannot cancel the t's because I have these minuses top and bottom. This is a nice simplified form. I simply box it, and that completes the podcast on literal equations.